Hello. In the last lecture, we find out the magnetic field at the center of the current carrying loop using Bioseverate Law. In this lecture, we will find out the magnetic field on the axis of current carrying circular loop. Consider a circular loop of radius A of center O through which a constant current I is flowing. The loop is placed in the YZ plane with its center at the origin. P is the point of observation and this line is perpendicular to the plane of the loop. The point P is at a distance x from the center of the loop. Point P is at a distance r from the two elements which are considering at the diametrically opposite ends. So both these current elements are at the same distance r. Here r is equal to under root of a square plus x square. So r square is equal to a square plus x square. This point, this distance r is at right angle to the plane of the loop. The magnetic field is perpendicular to the plane containing dl and r and its direction is determined using the right hand screw rule which we have discussed already. Phi is the angle. As with the change of the current element, the direction of the magnetic field changes. So we have to resolve it into the perpendicular and the parallel directions. The magnetic field due to the second current element, which is at the diametrically opposite end, is same, but direction is opposite. Again, resolving this magnetic field into the rectangular components. The components are dB cos phi and dB sin phi. As this component and this component are equal in magnitude but opposite in direction, so they cancel out each other and the net magnetic field at the point P due to the loop is only due to the component dB sin phi. Now, according to the Bioseverate law, this will be the Bioseverate law. Now put the value theta equals to 90 degree. It will give this relation. When we resolve the dB into the rectangular components, component cos phi cancel out each other and the net magnetic field is due to the sin phi component that is in the same direction. So net magnetic field is obtained by integrating the dB sin phi. Now put the value of dB which is equal to mu naught upon 4 pi IDL by r square. Now integration of the dl is 2 pi, right? And let us recall the figure. This distance is a, this distance is x and it is r, and r is equal to under root of a square plus x square. So r square is a square plus x square and sin phi, it is the phi. Sin phi is perpendicular upon hypotenuse. So sin phi is a upon a square plus x square to the power half. Now solving this, we will get this expression. Now the special cases. At the center of the loop, this point x is equal to 0. Now put the value of x equals to 0 in this equation, and it will give you mu naught I a square upon 2a squared to the power 3 by 2, which is EQ. So the expression which is left is mu naught I upon 2a. Now if the observation point is far away from the coil, then a is much smaller than x. In other words, a square is negligible. Now here is the x square. 2 से 2 cancel, so it becomes mu naught I a square upon 2x cube. Now this is a graph between the magnetic field and x. It is the center, and as we are going away from the center, the magnitude of the magnetic field decreases. Now it is a numerical. The electric current is flowing through a circular coil of radius a. At what distance from the center on the axis of the coil will the magnetic field be 1 by 8th of its value at the center? It is a magnetic field at a point on the axis of the coil, and it is a magnetic field at the center of the coil. According to the question, at what distance from the center on the axis? Means at a point on the axis. The field is 1 by 8th at the center. So it is the 1 by 8th of the magnetic field at the center. Now put the values of the magnetic field at a point lying on the axis of the coil and the magnetic field at the center, and solving it you will get the relation. Thank you and have a nice